algebraically, we've already used the quadratic formula. So now it's time to use the quadratic formula to help us with graph sketches. Just to recap, if we've got a trinomial, ax squared plus bx plus c, and we want to let y equal 0, i.e. this is the standard form of a parabola, ax squared plus bx plus c, and we want to find the x-intercepts which occur when y is equal to 0. If we solve this for x, what would it look like? Well, this is what's happened, okay? So someone has come along and solved the general form for x when y is equal to 0, and this is the result. And all it does is gives us the x-intercepts or solutions for x. All right, so there's a part of it, this part here, b squared take 4ac. That's what we refer to as the discriminant. And remember, if the discriminant is less than 0, there's no solutions, because you can't square root a negative number in methods anyway. If the discriminant is equal to 0, then we've got one solution. One solution. And if the discriminant is larger than 0, then what happens is we get the plus minus. We're going to get plus minus or two solutions. Okay, if we get square root 0, it's just 0. Plus or minus 0 doesn't exist, it's just 0. Okay, so if it's greater than 0, we do get the two solutions. Now, interestingly, if I remove the discriminant check from the quadratic formula, I'm left with negative b on 2a. Now remember, this plus minus portion of this is just the flip-flop either side of, so if this is a parabola, the plus or minus b squared take 4ac will be the flip-flop from the axis of symmetry. Okay, so if I remove the flip-flop, all I'm left with is the axis of symmetry, and there's a formula there. X is equal to negative b on 2a tells us the axis of symmetry. All right, now that's handy if we want to get the turning point of a function. All right, so let's try all of the techniques that we know out on the following trinomial. All right, so I'm going to note that the y-int occurs when x is equal to 0. So when I sub that in, I get y is equal to negative 3, 0, negative 3. All right, so there's the first thing that we've done. Okay, now what we're going to do is just check whether it does have x-intercepts. All right, so let's do a discriminate check on it. B squared take 4ac. All right, where a is the coefficient of the squared term, b is the coefficient of the x term, and c is the constant, negative 3. Right, let's bang them in. B squared is 16, take 4 times a is 2 times c is negative 3. All right, 16, that's 8, 24 plus 24. Discriminant is equal to 40. All right, so therefore, we're going to say that this has two solutions. All right, what are the solutions? The solutions are going to be, so let's use the quadratic formula. So x equals negative b, which is going to be negative 4, plus or minus the square root of b squared take 4ac. Now that's what we've worked out there, so it's just the square root of 40 over 2a, which is 4. All right, now what we want to do at this point is just make sure that we have fully simplified this, okay? So this one here actually would be x is equal to negative 4 plus or minus, and we're going to go root 4 times root 10, okay, which is 2 root 10 over 4. All right, and now we can further engage with this by saying x is equal to negative, let's pull out negative 2. And that's going to be 2 plus or minus root 10 over 4. Let's cancel that, 2, cancel that, which is 1. So this is x is equal to negative 2 plus or minus root 10 over 2. All right, so there's our two x-intercepts. All right, well, what about our turning point? All right, so I could use x is equal to negative b on 2a, and in fact I'm going to. Now, why am I going to do this? Well, because to complete the square where the coefficient is something other than positive 1, to me is, well, it opens up some issues with errors and things like that. So I'm going to use this, okay? So this part here is the axis of sim. It's x equals negative b, which is negative 4, all over 2 times a. So that's 4, which is equal to negative 1. Now what we're going to do is sub x equals negative 1 into this, and it's going to tell us a y value. So y is equal to 2 lots of negative 1 all squared plus 4 times negative 1, take away 3. Now that's going to be 2, take 4, take 3. That's going to be negative 2, negative 5. So our turning point is negative 1, negative 5. Now, anyone disagrees with me on that, go complete the square and see how long it takes you to get that same response as an answer. Okay, so axis of symmetry, negative b on 2a method can be very quick to get turning points. All right, and now we're ready to sketch. So let's draw up a Cartesian plane. And let's mark in our key points. All right, so we've got a turning point at negative 1. Let's pop negative 5 there. A y-intercept at negative 3. So here's negative 4, negative 3, negative 2, negative 1. So negative 3 is around about there. All right, so our axis is going to run along that line there. So we're ready to sketch this. The new version of the program. So I think it's got this smoothing option. All right, let's try this. That didn't really smooth it, did it? Oh. Anyway, that's my best effort there for the moment of getting that one done. Okay, so let's label our key features. So it's negative 1, negative 5. Our y-intercept is 0, negative 3. What are our x-intercepts? Well, one of them is x equals negative 2 plus root 10 on 2. That's going to be this one right here. So we can label that according to what the picture has come out like. Negative 2 plus root 10 over 2, 0. And this one over here is the other one. That's going to be negative 2 take root 10 over 2, 0. All right, so first sketch done. Okay, let's go another sketch. All right, so same process this time. Y int x is equal to 0. So bang that in, y is equal to 5. 0, 5 is our y-intercept. All right, what about our x-intercepts? Okay, so discriminant is b squared take 4ac, where our a value is 3, our b value is negative 6, and our c value is 5. All right, so let's sub in these values. So we've got 36, so negative 6 all squared is 36. Take away 4 lots of a, which is 3, and b, which is 5. 36 take away 4 3s are 12, 5 12s are 60. Discriminant is, what's that? It's going to be 24 negative. Discriminant is less than 0, therefore no solutions. So isn't it great to know that there's no solutions to this? So any attempt to factorize it, any attempt to complete the square to solve for x when y is equal to 0, any attempt to throw it all in the quadratic formula would be a waste of time at this point. Okay, so all I know is that it has a y-intercept at 0, 5. Okay, so this is what I know. This is my dodgy sketch just at this point, and it's going to have a turning point like here maybe, or here maybe. Okay, but that's all I know at this point. So the last thing I need, the only other thing that I need is the turning point. Now again, I could complete the square on that, but that is going to be a bit of a nightmare if I have a coefficient other than 1 before the x squared. So what I'm going to do is again use x is equal to negative b on 2a. So we're going to get the axis of sim. X equals, so our b value is negative 6, so negative 6 is 6. over 2 lots of A, 2 times 3 is equal to 6. That's 1. All right, so now we're going to sub x equal 1. All right, so now what we'll do is we'll bang that value x equals 1. So sub x equals 1 into y equals, and we take our original function, which was 3x squared. So we're going to go 3, 1 squared, take away 6, 1, what is it, plus 5, I think, from memory. All right, and that is going to be y equals 3, take 6, plus 5, which is 3 take away 1, which is 2. So our turning point now, girls, is 1, 2. All right, let's sketch this thing. Okay, so turning point is 1, 2. So we'll pop it in there, 1, 2, 4, 5. There is the y-intercept. Just do something symmetrical over there. Okay, so there is our sketch, 1, 2, 0, 5. Okay, so again, you can see here the benefit of looking at the discriminant check, of not trying to factorize it straight away. It'd be a waste of time. This again is a really handy thing to be doing. All right, final sketch, I think. Hard as it gets, this. Absolutely hard as it gets. All right, so our y int when x is equal to 0. In this form, it'll just be the constant. So 0, -9 is our y int. All right, so just quickly, let's have a look at that. So it's -9, and this negative sign out here means that our parabola is inverted. So it could be many things that happen now. It could be like that, it could be like that, it could be like that. We could get x-intercepts, we may not get x-intercepts. So why don't we check? Why don't we check whether we're going to get any by running the discriminant check? Where A, whoopsie, getting a bit messy there, A, C, where A is equal to -4, B is equal to -12, and C is equal to -9. Lots of negatives. So it's going to be B squared, which is 144, because -12 all squared is 144. Take away 4 lots of A, which is -4, times B, which is -9. So that's going to be 36. 4 lots of 36 is 144. That means the discriminant is 0. Therefore, 1 solution. Okay, so what that basically means is, if I know that the y-intercept is -9, we're going to get one of two things happen. It's going to look like that, or it's going to look like that. So our axis of symmetry is either going to be negative or positive. Okay. Now, what that also means is this is a perfect square. It has to be. Okay. So let's go ahead and work out how we're going to get this. Now, we don't need the turning point this time around. All we need is the axis of symmetry. We know for a fact that it turns on the x-axis because it's got one solution. So all I'm going to do is write x is equal to -b on 2a to get the axis. That's going to be -b, which is 12, -12 over 2a. 2 lots of a is, mental blank here, 2 lots of that is going to be -8, which is going to be -3 over 2. All right, so we can actually sketch this, would you believe, right now. I'm going to sketch it, and I'll just show you something once I've done that. All right, so the turning point is -3, oopsie. So that's the axis of symmetry, is it's going to turn there, and our y-intercept is -9. Put a point there, point goes there, draw the parabola. Okay, so there it is. Right, now what we could have done is, actually this will factorize to a perfect square. So we could actually test this out by going y equals, and let's pull out the negative, 4x squared, take 12x plus 12x plus 9, throw that on the cross and it'll be 2x, 2x, 3, 3. That's going to be 6 and 6. So this is y equals negative 2x plus 3. And then if I solve that to get the x-intercept, 0 equals negative 2x plus 3, all squared and all squared. If I divide by the negative, I'm going to get 0 equals 2x plus 3, all squared. Let's root both sides, which when I square root this left-hand side here, I'll get 0 as well, so that's 2x plus 3. And now let's solve it. Negative 3 on 2 equals x. So there we go, we've got the x-intercept as well, which is negative 3 on 2. So that's just another way of doing this problem.